any questions that people have, feel free to unmute and ask those questions. I'll also have a kind of a combined list of questions that have been coming across and also being answered in the chat. So feel free, anybody, if you have questions. One thing that I have, while everybody else gets their thoughts together, is so specifically AR, VR for pre-mission training. And so one of the things, and I have another question later on for navigation and orientation in the field being the moon in this case, is that, the disorientation that will happen and happen at Apollo and is likely to happen on the lunar South Pole is, just not understanding where things are, especially with navigational aids, and how AR, VR might really assist with getting oriented about the space that they're going to be operating in, and what you think about that and how that might happen.
I'm assuming that question is for me. Yes. Yeah, so I think that's why one of the advantages of using VR is we can do some initial site reconnaissance from using orbital data, just to at least to give us a general idea of where we're going to be and orientation of different features around us. So I think, that again is and it will be in a 3D immersive environment. So I think that is advantageous to be able to do that versus looking at something 2D in a map. Your mind will not be able to connect what you're seeing on the map versus what you're seeing in 3D as quickly as if you're seeing it in 3D initially, as you would in a VR environment. So I think that that's another advantage, is we can actually familiarize ourselves in a 3D way, the way we would be on the moon before we even get there. And then when we're there, then really get to those fine scale features that we're interested in.
Yeah, that's great. Thank you. Jim, I see you came on. Yeah, that's a question.
Yeah, just excellent presentations, and just a question for Fred. Really great summary of how the sausage is made. That's absolutely incredible. A great overview. Very informative. How do you see that sort of robotic dynamic changing with humans in the loop, in the sense that the astronauts on the surface will obviously have the best situational awareness, and how does one integrate the situational awareness that they will have, perhaps with IVR, okay, to optimize the science return?
So specifically, you're talking about like human robotic partnership, essentially on the surface?
Yeah, I was thinking about the ground, not so much robotic on the surface. It's more like, okay, so all the tools you're talking about is like, okay, you're dealing with a ground team, and then you're gonna transmit the commands to the spacecraft, okay, to the rover. And I'm thinking, okay, you're gonna actually transmit them to the crew, who have a huge amount of situational awareness. So yeah, so how do you take advantage of that coming back?
Yeah,
and then integrating that into the uplink, so to speak.
Okay. I I can't stress it enough, and I said it a few times yesterday. Localization is so important. These maps are useful, but not as useful, especially when you get to the meter scale of knowing where you are on that map. So I think there really should be a lot of thought and a solution made into a localization solution for the astronauts. Now, that said, because if you have that, then you can do things like, and someone mentioned about heads-up displays. Maybe there's a dot on your display that you have to walk towards. However, it would also be the case that if you have real-time tracking of an astronaut, then you can say, go more to your left. You can start to call out features as they're approaching. You can use view sheds to say, I like this happened in Jet 3, I think, that I observed when they were talking, and someone had said like, I think I see the lander, and someone made the view shed and said, yeah, you should be able to, or you should see the lander pretty soon. And then they're like, and they walked a little bit, and they're like, yeah, we see it now. So those type of being able to point to spatial cues, I think, will be very useful during the missions. But I think, I just feel like we need an excellent solution for where the astronauts are, more than I walked 10 steps past this big rock, And I think there are a lot of, quite honestly, very low tech solutions that you could use, measuring angles between known features that are in the distance. even a simple laser rangefinder, and into more advanced things like a total station, so that you could just have constant tracking of where you are. And I know that's like someone's going to say, yes, that's Artemis 4, that's Artemis 5, that's Artemis 6, but really, any mission on the surface should be having excellent localization capability for all the astronauts, if anything, just for a safety perspective.
So yeah, I want to follow up with that. That is more Artemis 4, Artemis 5, Artemis 6. And so, in the absence of localization, what do the maps and what does this kind of web-based integration help with? So if you don't have those things, which, is everybody understands that that's what we would love to have. If we don't have those kinds of things, and even if we did have those kinds of things, but they weren't necessarily working, how can the maps be working together and the crew? So maps, crew, and then backroom all working together to localize. Do you have ideas with that? And Matthew, you can jump in here too if you have any ideas.
I think, knowing the lander orientation and your view to it is certainly going to help. You can certainly do the classic field stuff, count paces if you wanted. I think it will take someone in flight and I'll let Matthew feel this, but like being actively keeping track of where they are. But I think also like it would be nice, and there's a little bit of conversation about it, that having a better high resolution base map of your local landing site is important. And some, you mentioned like EDL. Absolutely. We did that for Perseverance. We took one of the EDL images and used it to do localization, but also to get a high resolution data set for driving the rovers, but that can be for walking. That would be very useful. But I think also I know it's about a solution, but having a map on surface for the astronauts to use or to look at would be very useful. And I would want it to be active and not static, but it would be a start. And then they could start, even if they're hand marking up the map, to say, okay, here's the lander, here's the the front of the lander, and now I'm looking at, and then I can kind of pace myself around and make some guesstimates. I can see this boulder, I can see this crater, and so on.
Yeah, thanks for that. Matthew, do you have anything to add to that? No pressure, just if you had a comment.
No, nothing to add. Concur that localization is super important.
So as far as the map book goes, that is something that is being actively worked on, has been worked on in JET and will continue to be. And it's an interesting point, because what the crew said last year was that it was absolutely critical to have these products. And so there's been a lot of conversation about which products do they gravitate towards more. Was it a personal preference? Like, would different people want different things? How would they want that information conveyed? And so, yeah, those map books, so the hard copy map on the surface, even if you had localization, obviously some kind of like pad or something like an interactive pad would be much better. But having those hard copies on the surface so you can localize yourself is absolutely critically important. It's something that's certainly being discussed. Jim, do you still have your hand up? Another question?
No, sorry.
Oh, that's good. Any other questions?
Can I address a couple of the questions that were in the chat?
Absolutely. Yep.
Okay, great, thanks. So one of them was about micro scale features. And yeah, so that's one of the challenges of the data integration is experimenting and understanding what scale features are the most appropriate for what fieldwork we want to do. I think crystal size and vesicularity are obviously very, very important for being able to characterize a site. So I imagine in that scenario, it would just be about, how much coverage you can get for an area that you're looking for at that scale. And then just zooming in, while you're in the VR environment, that's the great thing about it is you can sort of manipulate your environment to whatever scale you need it to be while you're standing there. And then the other question was about the activity we did with the high school students. Yes, they loved it. They provided very useful feedback. We were just so excited to see that they were actually getting some of the field geology principles that we were trying to teach them, and they understood the importance of studying features on Earth to connect to what we're understanding on other on the moon and other planets. So they gave us we were just really excited how much they were into it. We knew it would be engaging, but it was even more engaging than we thought it would be going in. So it was a great experience to see that really did capture a lot of people's excitement for lunar science.
Yeah, that's great. Love to hear that. One last comment. I see some comments going through, and Wayne had put a comment in there about having a plan at NGA to build mission maps that have a lot of survival uses. And that's good to see. And one of the things that this workshop is supposed to do is bring people together so that we're not missing out on bodies of expertise. And so certainly this is a collaborative environment, and we want to make sure that we are using each other to the extent that we can in a good way, and leveraging those bodies of expertise. So as people work on different things, we certainly should be communicating together and making sure that that we can move the ball forward as a community instead of replicating work and keeping things isolated and siloed. So let's keep that in mind as we move forward. Thanks everybody for the discussions. It's been really good. Enjoyed that last session.